Okay, now we're going to talk about a different method of solving these systems of equations. And it's important to know how to do multiple different types of ways of solving these systems of equations. We've talked about graphing, we've talked about solving by substitution. This one now, solving by elimination, is just another tool that you like to have in your toolbox to be able to solve these systems and find out where is the intersection point, or where, at what ordered pair of values would make this both equations true. So let's go back to our original question. If we add two numbers that equal 10 and subtract two numbers, the same two numbers that equal 10, what numbers make that true? And we already know that it's 10 and 0 is the ordered pair that would make that system true. Now, talking about elimination, this method is where we take the first equation and the second equation, and we take the fact that if we subtract both sides by the same quantity, right, the equation holds true, right? So if I had, the score of the football game was 10-10, right, and then each team, I don't know, we took away 3 points, right, from both teams, they would still be, it'd still be tied, right, and still be equal to each other. So again, this x plus y is just equal to 10. It's a value of 10. And this x minus y is equal to 10. So we have two things that are equivalent to each other. If I want to, let's just add. How about we add, right? If we add, 3 to both sides, we'd get 13 equals 13. And we still have an equation that's true. So if I take this is equal to 10, and this is equal to 10. If I add both to both sides of this equation, the value of 10, but in this case I'm going to add just x plus minus y, which is equivalent to 10, and this I'm going to add 10, it's okay. I should get an equation that is also true, right? And the idea here is I'm going to do this because when I add these two equations together, so I get x plus x, which is 2x's, and I get y plus a negative y. Well, y minus y is just 0, so I get, well, let's just say 0 y's, and 10 plus 10 is 20. Then this 0 times anything is just 0, drops out. And we call this the elimination method because of that. We want to make one of these variables drop out, so we're only left with a single variable, which we know how to solve, right? So this we just divide both sides by 2, and we get x equals 10, which we already knew. And then if I want to find the other variable, all I have to do is plug that value of 10 using the substitution method into either one of these equations. So I say 10 plus something is equal to 10. Well, that something has to be 0. Or I say 10 minus something is equal to 10. Well, that something has to be 0. So just I'll write it out. 10 minus y equals 10. So I subtract 10 on both sides. I get negative y is equal to 0. So that means y would have to be equal to 0 if I divide both sides by negative 1. Okay, so that's solving by elimination. Let's do a little bit more complicated one as well. So how about I have 2x plus 3y is equal to 6. I like this one for some reason. And let's just say negative 4x plus y is equal to 10. Alright, so this one, when I add them together, nothing's going to drop out. So I have to do something to make the equation eliminate something when I add it together. So what I want to do is have an opposite there. If I had 3 and negative 3y, then it would drop out, right? So let me modify this equation just by using my property of equality. I can multiply both sides of the equation by negative 3, and it will still be another equation that's true, right? Again, if I had 10 equals 10 and I multiplied both sides by negative 3, I'd have negative 30 equals negative 30, so it would still be true. So I'm going to multiply this whole equation by negative 3. So it turns into negative 3 times negative 4 is positive 12x. Negative 3 times y will be negative 3y. And negative 3 times 10 is negative 30. So I have this new equation that is also true. And I'm going to add it to my original equation. 2x plus 3y is equal to 6. So when I add these together, this will eliminate, right? So 12 plus 2 is 14 x's. 0 y's equals negative 30 plus 6 would be negative 24. And then I divide both sides by 14. So I get x is equal to, let's see, I can reduce that. Divide both by 2. So it would be 7 and negative 12, so negative 12 sevenths. And then if I want to find the value of y, I take this and I substitute back into either equation. Any of these equations will work. It's kind of messy. Let's say, I'll just take the top one. So now I solve this for y. So this would be negative 24. So I'm going to negative 24 sevenths plus 3y equals 6. Add 24 sevenths to both sides. So that makes 0, and I have 3y is equal to, let's see, 6 times 7 would be 42. So 42 sevenths is equivalent to 6 plus 24 sevenths. And so 42 plus 24 is 66 divided by 7. And then I divide both sides by 3. So I'm going to have y is equal to 66 sevenths divided by 3, which is the same as multiplying by 1/3. So I get 66 21st. And I could divide both those by 3 actually. Sorry for the more difficult arithmetic, but it's 22 sevenths. Hey, that's my approximation for pi. Totally random, but came up with that. Okay. So y is equal to 22 sevenths and x is equal to negative 12 sevenths would be the solution to this the system of equations. If I were to graph them, this is where the intersection point would be, and I have a single solution.